Imagine this: scientists at CERN stumble upon a discovery so profound that it rewrites the very fabric of our understanding of the universe. Could such a revelation be on the horizon? CERN, the European Organization for Nuclear Research, has long been at the cutting edge of scientific exploration. Since its founding in the 1950s, it has served as a beacon of innovation, boldly pushing the boundaries of what humanity knows about the cosmos. In this video, we'll unravel some of CERN's most groundbreaking experiments, dive into the mysteries of the Large Hadron Collider, LHC, and explore recent findings that might shake the foundation of physics as we know it. What are the implications of these discoveries? Could they alter our perception of reality itself? Let's journey into this fascinating realm together. Nestled along the French-Swiss border, CERN has been the stage for countless scientific milestones. From deciphering the mysteries of antimatter to uncovering the Higgs boson, this organization is no stranger to making waves in the world of science. But what drives these efforts? At its core, CERN's mission is simple yet monumental: to understand the fundamental building blocks of the universe and the forces that govern them. One of CERN's crown jewels is the Large Hadron Collider, the world's largest and most powerful particle accelerator. Picture a machine so massive it spans 27 kilometers in circumference, buried 175 meters underground. Costing over $4.5 billion to construct, the LHC represents a global effort involving thousands of scientists from over 100 countries. But what does this colossal machine actually do? The LHC is designed to accelerate particles, such as protons, to nearly the speed of light, 99.999991% to be exact. These particles whiz around the collider's loop over 11,000 times per second, guided by electromagnets that are more than 1,000 times stronger than the Earth's magnetic field. When these particles collide, they release tremendous energy, creating showers of new particles. These fleeting particles exist for only fractions of a second, but during that time, they hold the keys to unlocking some of the universe's deepest secrets. Every collision within the LHC generates a wealth of data, so much, in fact, that CERN collects over 15 petabytes of raw data annually. To put that into perspective, 1 petabyte equals about 250,000 HD movies. By 2017, the LHC had stored over 200 petabytes of data, an amount so vast it requires specialized computing systems to analyze. This data isn't just numbers, it's a treasure trove of information that could help solve some of the universe's biggest mysteries. One recent anomaly, for instance, involved the behavior of beauty quarks, fundamental particles that seem to be decaying in unexpected ways. Quarks, the fundamental building blocks of matter, come in 6 flavors, with the beauty quark being one of the most intriguing. According to the Standard Model, beauty quarks should decay into lighter particles, such as electrons or muons, in equal proportions. However, the LHC found that beauty quarks were decaying into muons 70% of the time, a stark deviation from the expected 50-50 split. What does this mean? It could indicate the presence of an unknown particle influencing these decays, hinting at new physics beyond the Standard Model. Some scientists believe this particle might even carry a previously undiscovered force of nature. The Standard Model is the framework that explains the behavior of most known particles and 3 of the 4 fundamental forces: electromagnetic, weak, and strong forces. However, it falls short in explaining gravity and dark matter, which together shape much of the universe. Discoveries like the beauty quark anomaly suggest there might be more to the universe than the Standard Model can explain. Could this lead to a new understanding of the cosmos? Among the theories gaining traction is the existence of a particle called Z prime. This hypothetical particle could represent a 5th force of nature, one so subtle that it has eluded detection until now. If confirmed, Z prime could revolutionize physics, potentially unifying all fundamental forces into a single framework, a dream scientists have pursued for decades. No discussion of CERN would be complete without mentioning the Higgs boson. Discovered in 2012, this elusive particle is responsible for giving mass to other particles, making it a cornerstone of modern physics. Without the Higgs boson, the universe as we know it wouldn't exist. But the Higgs boson is still shrouded in mystery. CERN's ongoing experiments aim to uncover its deeper properties and explore whether multiple types of Higgs bosons exist. CERN's groundbreaking work hasn't been without controversy. From fears of doomsday scenarios to wild theories about opening portals to other dimensions, the public imagination often runs wild. One persistent theory is the so-called Mandela effect, where people believe CERN's experiments have altered reality itself. While these ideas make for compelling stories, they underscore a deeper truth: humanity's fascination with the unknown. With plans to upgrade the LHC and explore even higher energy levels, CERN is poised to make even more discoveries in the coming decades. These advancements could answer some of the most profound questions about the universe, or raise entirely new ones. Are we prepared for the implications of uncovering the unknown? Could these discoveries fundamentally change our understanding of existence? As we stand on the brink of potential scientific breakthroughs, one thing is certain: the journey to understand the universe is far from over. What are your thoughts on CERN's work and its implications for humanity? Leave your comments below and don't forget to like, share, and subscribe for more deep dives into the mysteries of science and technology. Together, let's explore the frontiers of knowledge. Since its inception in the 1950s, CERN has been a beacon of international collaboration, bringing together some of the brightest minds from across the globe. Its founding was a bold statement during a time when the world was still recovering from the Second World War, a declaration that science could transcend borders and unite humanity in the pursuit of knowledge. Today, CERN stands not only as a hub of scientific discovery but also as a symbol of what humanity can achieve when we work together. Among CERN's crowning achievements is the marvel of engineering and scientific ingenuity. Stretching over 27 kilometers in circumference, this incredible machine has been the site of some of the most groundbreaking discoveries in modern physics. From the confirmation of the Higgs boson in 2012 to ongoing research into the mysteries of dark matter, the LHC continues to challenge our understanding of the universe. The LHC works by accelerating particles, typically protons, around its vast loop at speeds approaching the speed of light. To achieve this, it uses an intricate system of, cooled to temperatures colder than outer space, to steer and focus the particle beams. Once these particles reach their maximum speed, they are smashed together in high-energy collisions, recreating conditions similar to those just after the Big Bang. These collisions are not just a spectacle of energy, but a treasure trove of data. Each second, detectors capture millions of particle interactions, producing petabytes of information. Analyzing this data requires cutting-edge computational tools, and it is through this painstaking work that scientists uncover the secrets hidden in the subatomic world. When that was finally discovered, it marked the culmination of decades of theoretical and experimental work. But what exactly is the Higgs boson, and why does it matter so much? To answer this, we must delve into the very fabric of reality. The Higgs boson is linked to an invisible energy field that permeates the universe. This field is what gives particles their mass, a fundamental property that allows matter to exist in the forms we recognize. Without the Higgs field, there would be no atoms, no stars, and no life. But the discovery of the Higgs boson was just the beginning. Scientists are now probing deeper into its properties, hoping to uncover clues about the early universe and the forces that shaped it. For instance, understanding how the Higgs boson interacts with other particles could reveal why the universe is stable and not prone to collapse into chaos. These are questions that touch the very essence of our existence. One of the most intriguing recent findings at CERN involves the behavior of also known as bottom quarks. These particles, which are among the 6 flavors of quarks, have shown unexpected decay patterns that defy the predictions of the particle physics. In simple terms, the Standard Model is a theoretical framework that describes the behavior of all known particles and the forces that act upon them, except gravity. It has been remarkably successful, but it is not complete. It cannot explain phenomena like dark matter or the nature of gravity at the quantum level. The anomaly observed in beauty quarks could be a sign of something new, a particle or force that lies beyond the Standard Model. Some scientists have speculated about the existence of a particle called which could mediate a new force. If confirmed, this would be one of the most significant discoveries in the history of physics, opening the door to a deeper understanding of the universe. CERN is not resting on its laurels. Plans are already underway for an upgraded version of the LHC that will produce many more collisions per second. This will allow scientists to gather more data and increase the chances of observing rare phenomena. Beyond the LHC, CERN is also exploring the possibility of building a next-generation accelerator, tentatively named the. This machine would be even larger and more powerful than the LHC, capable of probing the deepest mysteries of the cosmos. Despite its achievements, CERN has not been immune to public scrutiny and speculation. Conspiracy theories ranging from concerns about black holes to claims of interdimensional gateways have occasionally captured the public imagination. While these ideas are not grounded in scientific reality, they highlight the need for effective science communication. CERN has taken steps to engage with the public, offering tours, educational programs, and interactive exhibits. By demystifying its work, CERN aims to inspire the next generation of scientists and foster a greater appreciation for the value of fundamental research.